All right, here's a video just to kind of help you with homework 10. So problem 1, what you have is a tanker with a pump, and you're pumping this liquid fertilizer to this point. And what they're saying is right inside the hose here, it's 140 kilopascals. So it's not outside where it's atmospheric. It's right inside the hose. Okay, so if I zoomed in, let's just do this. Okay. Or let's just make it a hose. Let's just do boom, boom. It's like right inside. And I would call this point 2. Then I would call point 1 right there. Okay, again, write your modified Bernoulli's, which is P1 over rho G plus V1 squared over 2G plus Z1 plus HP minus HT minus HL equals P2 over, rho G plus V squared 2 over 2G plus Z2. Okay. Now, remember that P1 I would cancel because that's atmospheric. Velocity at 1 is also 0. Okay. And I believe there is an elevation change, but I guess I would maybe call this your datum. So then you have Z1 and Z2. Okay. I believe there is no minor losses. Okay, so it doesn't give you anything about that, but it does tell you the length of the hose, so there is a major loss. Okay. So, is there anything else? Yeah, there's no turbine. Okay, so you can break it down, solve for HP, find HL, right? All right, you're going to need Reynolds number, you're going to need F, and then finally you're going to figure out all of these to then go back and solve for HP. And then you can use what we had in the pump lecture. What was it? Rho G V dot times HP. Okay. So that should get you started for part 1. Part 2, you can go 1 to, I would maybe call this just for now, maybe 3. Or you can go, for part B, you can go 1 to 3. Or you can go 3 to 2. Or if the 3 is confusing you, just change that to A or something. Okay. I'm just doing 3 just as another state in this case. Okay. So you can pick which one you want to do and write your modified Bernoulli's, and you should be able to find the pressure at that point. Okay? So that's problem 1. That should give you enough. Problem 2, we have a water pump, maintains pressure 6.5 psi right after this. So I would say right here. It's after the pump. There is a filter, a half-open disc valve, 2 regular screwed elbows. There are 80 feet of 4-inch diameter commercial steel pipe. If the flow rate is 0.4 feet cubed per second, what is the loss coefficient of the filter? Okay. And then the bonus is if the disc valve is wide open in the K filter 7, what is the resulting flow rate? That one's tricky, and I'm pretty sure I have a video on this to help you with that one. But what I would do is, again, write modified Bernoulli's and then cancel things. All right. And you'll end up basically solving for HL, and then you can then write out HL. And you'll see that the the K of the filter is missing, so you can solve for that one. Okay. So modified Bernoulli's, cancel items. I would go from state 1 to state 2. You're going to notice, like, we don't have the pump in that section. So that pump can go out. There's no turbine. Okay, so what you can do is you can technically solve for that HL value, which we know that HL has major and minor losses, right? And I've given that equation to you. Okay, so you can write that fully out, and then you'll notice, the filter's missing. You can rearrange and solve for the filter. All right, this should help you with homework 10. If you have questions, let me know. Thank you.